Hey, this is Don from Padlock Technologies with another video. This time, we are going to talk about something I think I talked about before, but I was having some conversations with a person that I am on LinkedIn with. I enjoyed the conversation, but I'm actually doing this video based on the conversations we had, and we are going to talk about MVPN again, but we're going to specifically talk about the different flavors, right? So there's GRE-based ones, and then there's MLDP, right? So in this lab that I'm getting ready to show you, I actually have both. Now, in the real world, will you see a mixture of both GRE-based and MLDP-based? No, you're not going to see that. Most of the time, service providers are going to do one or the other most of the time. I know there's some outliers out there, so I don't want to say 100% yes or no to that, but for the majority of the time, you're going to see either GRE-based or MLDP-based. What's the difference, right? So the difference between the two, if you're going to do the GRE-based profiles, which in the Cisco world, they really teach you profile 0, which is draft Rosen, which is old school MDT. Then you have a MVPN, uh, AFI, sub AFI. So the old draft Rosen profile 0 is AFI, sub AFI, IPv4 MDT. So IPv4 would be the AFI, the sub AFI will be MDT, and then the new styles, which is like three, as well, technically is 1, 3, 11, and 13 is the one they really want you to do in at least the Cisco world. Um, one is going to be MLDP based. Now the difference with that is with the GRE based ones, you got to run PIM in the core, right, in your core network. MLDP is exactly what it sounds like. You're just going to use an extension of LDP for multicast, right? So you don't have to run PIM in your network, right? Now the drawback to that is MLDP is pretty much ingress replication, right? You got to have you have to specify a route into your network. That route will then take once it receives a packet with that label on there, a specific label, it will ingress replicate, meaning just replicating the packets one at a time to each of the nodes, right? So in this example, you're going to see, I believe I did profile 3 and profile 1. So I'm not using BGP for signaling or CPIM signaling. CPIM is customer PIM, PPIM is provider PIM. So you won't see anything other than a type 1 route in the BGP IPv4 MVPN table. I know that's a mouthful. If I was using BGP for signaling, then you'll have a shortest path tree type, which is type 7, and then you'll have a shared tree, which is type 6. But you're not going to see that in this scenario. You're just going to see ones. So let's get to the lab and actually test it out. I'll show you. So this is the lab. You know what it is. You've seen this lab plenty of times. Now the difference is I removed the iOS XRs, put the iOS XEs, and as you can see, it's LDP based. I'm not using segment routing in here. Now, router 2 is the root of the MLDP based MVPN, and then I'm using SSM default. So you know what that is. That's going to be your 232x whatever subnet. And right now, this BGP up here, so this gray area, as you can see, MVPN profile 3 correlates with this MVPN profile 3 down here. And then we have MVPN profile 1, which is MLDB based. Now, this is going to be static routes, but I also did some route leaking from OSPF. So this area here is also going to be a part of the MVPN profile 1. And that's only possible because I'm importing and exporting the route targets. Remember what I said before in previous videos when you're talking about the VPN v4 table, when you do the route target import and route export command, all you're really doing is importing routes into the VPN v4 table and then exporting routes from the VPN v4 table. So as long as you import the correct route in your VRF, you basically leak routes in between the two. Okay, so from a multicast perspective, so 3, our profile 3, I have multicast going into the core right now. And right now I'm only using 3 and 1 for this one for the GRE base. So if we roll up into 3 real quick, we roll up into 3. And then if I go show IP PIM VRF, I believe it's cus a neighbor. Now you see that tunnel interface there, right? So that tunnel interface is technically my GRE tunnel, right? And that GRE tunnel is going to, I believe this is going to 1, right? Because I'm on router 3. So if I look at my PIM neighborships for that, if I go show IP PIM VRF cus A neighbor, you'll see my neighborship to 1 is going over that GRE tunnel, which I'm doing the multicast over, right? So you see PIM right here. I did the PIM neighborship. So you see I'm doing a VRF based PIM GRE tunnel, or doing a GRE tunnel, then I'm running PIM over so that I can share, multicast traffic. Um, and the difference with the MLDP based ones is it's not going to be a tunnel. It's going to be this thing called a label switch path interface. So it's going to say LSP interface, whatever the interface number is, right? Because you're using MLDP. So now that's basic stuff. Oh yeah, I need to show you the actual routes too as well. Let me not say that. So if I go show in the global routing to M route, now as you can see, here is technically, this is my type 1s, and this multicast group is for VRF cus A. So if I look at VRF, my VRF here for customer A, you can see right here is the default, which is what they're gonna do to join the MDT, which is the multicast distribution tree. And then this is technically what you would call a PMSI, or provider I think it's multicast source interface. Don't quote me on that. I always forget what PMSI is, what the name is. And then this is your data MDT. Now the data MDT is used for optimization, right? Because if you go over a certain threshold, you just don't want to bomb the default MDT. So what would happen is if I go over a threshold, I think this is 10 kilobytes. Once I go over that, everything will switch over to the data MDT, and it'll use a 232.2 something address instead of this multicast address to send the multicast traffic to its peer. So it's kind of an optimization thing. All right. So from there, if we do show IP M route VRF cus A, you will see that I am looking for, this is my shared T, this is your star comma G. This is why you need to know multicast before you even get into this. So your shared tree is going to be a star comma G. Your source tree is going to be a S comma G, meaning you know what the source is. The only reason why you have a rendezvous point is when you don't know what the source is, right? The rendezvous point is supposed to tell you where it is. So once I start doing the traffic again, or I'm gonna show you where I send traffic to that IP address, which is this 224, this multicast address. When I get replies, we'll go back and look at the M route table for this VRF, and then you'll see a source comma G. All right. So let's say we'll do router 2. And what I'm gonna do, I think what's gonna respond here is router 1 and router 2 in customer D, I believe. Oh, actually, and router 4 in customer A, right? So 1 and 4 should answer this. So let's go ping 224.1.1. I'm going to repeat 5 times. So we should get some answers here. So here's our answers. This is the multicast happening. Obviously, it's going through the GRE tunnel as well. So we're going to wait for some responses here. So that's router, which one is that? That's, okay, so that's router 2. Oh, I know why. Router 2 is responding because router 2 is a part of this. I should have did it from router 1. So the only one that's going to respond is 2 and 4, which is it's doing right now. And the reason why it's responding is because on the loop back at 2, I have a IP IGMP join 224.1.1.1. So obviously, if I'm on router 2 and I send it to that multicast address, router 2 is going to answer. So I should have did it from router 1. So if we go back to the route though, now you see we have our source comma G's, right? Somebody wants to, so we're sending traffic, and now we have our S comma G's, and then we have our star comma G over here. Now, if I did biter, then it would just be all, it would be a shared tree and never a source tree. That means you can go up and down the multicast tree. Traditional multicast, you can only go down the tree. You can never go back up the tree. Okay? So that is, I'm gonna not gonna waste my time with that. That's, we know it's answering, so we got our S comma G's here. So that is the GRE based MLDP stuff. So what does it look like for the, oh no, that is the GRE based multicast stuff. What does it look like for MLDP? So MLDP, I have a VRF called CusD. And the only reason why I have CusD, you got to be careful with this, is because when you do MLDP base, once you have a VRF that already has that, you can't do another, you can't have the same VPN ID in another VRF different name. So you're going to see, like for my customer Bs and stuff like that, I'm still using VRF CusD because I did the route leaking. So if we look at the VRF here, and here's the cusd. So just like similar to like VPLS and stuff like that, you gotta have your, I don't know why that did that. You gotta have your VPN ID. So this is the VPN ID that I'm going to use to join the tree, right? To join the multicast distribution tree. Now this root is, or this command, the default MPLS MLDP IP address, that's a loopback on router 2, and that is the root of this multicast tree. So I'm going to send my packets to that IP address, and then router 2 is going to do the ingress replication. And then we have our route leak in here, which I'm importing this 2044 so that the OSPF routes can come in, right, to my other VRF that is just static routes. So we're good there. And as you can see, here's my static routes for this router down here below. So if I were to look in there, CusD, as you can see, we got BGP routes, we got static routes, we got all that. All right, so that's going to replicate over. All right, that basically, I see all the routes. Everybody's good to go in terms of multicast. So what does it look like from a PIM standpoint, though? So if we go into show IP PIM VRF CusD, I think it's neighbors. As you can see, LS, now remember it was a GRE tunnel, right? For the GRE base MLDP. All right, the GRE base MVPN. I don't know why I keep saying that. Now for this one, it's going to be the LSP virtual interface. Okay, so now what's going to happen is you're forming those adjacencies over this virtual tunnel interface or this LSP interface and not over a GRE based tunnel, right? And again, the benefits of this is not having to run PIM inside your network or multicast inside your network. So now that we're here with MLDP, let's look at router 2 so I can show you that ingress replication piece. So if we go to router 2, which is in the center here, and we look at our show, I think it's MPLS MLDP bindings, I believe. And there we go. So once this is the local binding and this is the remote binding. So basically, if I send packets to this label, it will send it out that label, right? This is just ingress replication, and this is what the root of the tree is supposed to do compared to multicast or GRE-based multicast, which is just, you got multicast running in the core, network handles all of that. This is ingress replication. So I'm going to get the packet, and then I'm going to copy that packet, duplicate the packet again, send it off. So it's okay. It's a pro because you don't have to run multicast, but it's a con because it's ingress replication, in my opinion. All right, now I'll do Wiresharks for both so you can see what the packets look like. So what's going to happen is I'm on router 1, and I'm going to ping the address. I believe it was 224.211, and then we're going to see what replies. 224.211. I'll repeat it let's say 4 times. And in the meantime, while that's happening, I'm actually going to run up Wireshark too as well so you can kind of see it. It usually goes through, what interface is that? All right, that's G1. So let's capture if this just act like you got some sense here. Slide this over here. And this is why it's important to just not know how to configure this stuff. Know what it looks like in Wireshark. So when it goes wrong, you're like, oh, I know exactly what to look for. All right, so we're going to repeat this 4 times. And there we go. We got some responses there. I'm going to stop Wireshark. And let's just look at some stuff. So here's the request. And as you can see the labels going on there. Now let's look at the reply. This is all labels. And as you can see here, we got stuff responding to my replies. All the MLDP stuff. Let's go here. Let's look what that looks like. Here's the package again. Now you see that label right there? That's one of the labels for ingress replication. Right there. The 20. Maybe I can expand this just a little bit so you can see it. The label 212, that was one of the ingress replication stuff. Let's see what else we got here. And as you can see, I'm sending it to our multicast address. All right. So here's the destination. Here's it in the MLDP-based packet, or the label that's put on top of it. You can also see that's the bottom of the stack label because that S is 1. But then you can see the PIM stuff. Let's see. That's ICMP, ICMP, ICMP. I see. Now you can see my package just going like nuts right now. All right. Here's the PIM join. All this stuff is getting put in a multicast pack, a label. So that's what MLDP base looks like. So now we're going to go back to router 1 here. And I'm going to do this the right way. And I will do G01 again. But this time you're going to see it in a GRE packet. At least that's what we should see. So let's slide this over to this, make this a little wider. Let's go up here. We are going to ping that address again, but this time we should see it in a GRE tunnel. And there we go. Let that go off a little bit. So we got some responses, but I want to look at the packet though. So there are register messages for the source register. And there you go. GRE tunnel. So that's what you're going to see on the back end, because MLDP, you saw it was in a multicast, it was an LDP label, right? Because MLDP is basically an extension of LDP. And then for your GRE base, because this is profile 3, you're going to see it in a GRE tunnel, right? It's going to be GRE header, and then you're going to have your PIM going through there. So that is really the difference between the two. But you should know how to do both, especially if you're going for like service provider, or you're talking to service providers about using multicast to kind of stream stuff in your network. You need to know what they're really talking to you about. Hey, they say, yeah, we're using profile whatever. You should have some kind of understanding what these different profiles do. Right now, if I was doing a BGP overlay for this, then I would show you the BGP types, that the 6 and the 7 and stuff like that. But I'm not doing it on this one. And that's really it about different versions of MVPN. This one you saw was 1 and 3. So if you enjoyed this video and you got some value out of it, please don't forget to share, comment, like, and subscribe to the channel. Appreciate it if you do. Doesn't cost you anything but a click of a button. This is Don from Padlock Technology again. Thank you. and have a nice day.